Welcome, everyone. This is Module 1, Part 1 of Statistics, and we're going to start off with some definitions, and we're going to start off with data. The most important things that we can get for statistics. Data is a collection of observations, such as measurements and survey responses. And this is the plural of the word data. The singular is datum. Second definition is the word statistics. Is the science of planning studies and experiments, obtaining data, and then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the data. The better the data that we have, the better our results are going to be and more accurate we will be able to use our statistics. Number 3, a population. Is the entire group being studied? Most of the time we don't have access to the full population. Usually we just have grouped to a sample, which is going to be our next word here. But you can imagine trying to get the entire population of the United States or even the state of California or something like that. It's just not realistic, even when we get to a census, which is going to be another one of our words here in just a moment. So a sample is a subset of members selected from the population. Now this it says members, it doesn't have to be people necessarily. So whatever group it is that we're looking at, usually we can't get the entire population. We would just have to get a sample. And we will talk at some point about how to obtain good data that's a sample from the population. Number 5 is the census. And this is the collection of data from every member. Again, this is usually not possible. In the US, we do have the US Census, and they try to get everybody, but realistically, in fact, they use statistics to account for about what % of people we are missing. Now, we have 2 types of statistics, and the first part of this semester is going to be on descriptive statistics. And descriptive statistics consists of organizing and summarizing data through numerical tables and graphs. So this is after we get the data, we organize it in some fashion, and we can present it to someone and say, hey, here's the information that we've gathered. The better, which is the second half of the semester, are the inferential statistics. And the word infer is in there, and we'll get to that here in a second. Inferential statistics uses methods that take a result from a sample, extend it to the population, and measure the reliability of the result. We're going to do a lot more of that later, and I have a little drawing down here for you to explain that a little bit better in a second. Number 8 is a parameter. Is a numerical measurement describing some characteristic of a population, and usually for this class, we're going to be analyzing the mean. We'll talk about what that is here in a second, standard deviation, or the true proportion. And we'll get to all those eventually. Number 9 is a statistic. I know we have that up there. This is a general description. This is a statistic is a numerical measurement describing some characteristic of a sample. So you can see this one's of a population, the parameters with the population, statistics with the sample. And usually that is going to be here, here, or here. We don't have to know what those are right now. We will come back to those for sure. And our last definition is our sampling error. And you can read through the definition on your own. Sampling error basically is when we are taking a sample instead of the entire population, we understand that there's going to be some error in there because we're not going from the entire population. Now, here's how this works. You can see that this is a Greek letter mu. This is pronounced mu, that's how you pronounce it. It's a Greek letter M, and it represents the population mean. And what we do is we take a sample, and the sample is going to give us, this is called X bar, is the statistic. It's from the sample. And once we have the sample, what we do is we come to some conclusion from the sample, and then we can infer something about the population. So it's pretty cool stuff. And there's lots of ways on how do we get a good sample? How do we collect the data? We want to make sure that we don't have bias and that kind of things in there. Next page. So we're going to practice a little bit. So determine which underlying values are statistics, which are parameters. Now, if you remember from our definition, statistic has to do with the sample. Parameter has to do with the entire population. All right, so in a national survey, 72% of parents reported worrying about saving for college. Now, national surveys are never the entire population. It's just a portion of it. So this is definitely going to be a statistic. Next up, only 12 men have walked on the moon. Hopefully that will change soon and will include women. The average age of these men at the time of their moonwalk was 39 years, 11 months, and 15 days. Now, this is a parameter because it's taking into account all the people that have walked on the moon. So this is a parameter. Now you might be thinking to yourself, that's only 12 people. Yes, those are all 12 of the people who have ever walked on the moon. So that's the 100% the population that have walked on the moon. A study of 100 adults who used public transportation in San Francisco found that 86% felt the system was reliable. In this case, that's only 100 people. We know that more than 100 people use public transportation in San Francisco. So this is definitely a statistic. And the last one, upon opening their box of all, there's a keyword there, of their Christmas ornaments, a family found that 4% of them were broken in the move. So this is because it's all of their Christmas, this is going to be a parameter. All right, definitions here. All right, so a few more definitions here. This is a voluntary. Response. Sample. Is one in which the respondents themselves decide whether to be included or not. And now we have our here. So we have two types of significance. The first one is statistical. Significance is achieved in a study when we get a result that is very unlikely to occur by chance. Usually less than 5% means it's not statistically significant. More than 5% it is. And our next one is practical significance. It is possible that some treatment or finding is effective, but common sense might suggest that the treatment or finding does not make enough of a difference to justify its use or to be practical. So maybe the study says what it's trying to achieve, and then after it says that, you have to make the judgment call. Is that worth my time? Like, is that even worth doing? So let's do a little practice with that. And we're going to determine if it's statistical significance, practical significance, and why. So the first one, we have in a study of weight loss program, 5 subjects lost an average of 45 pounds. It is found that there's about 39% chance of getting such results with a diet that has no effect. So in this case, Does the weight loss program have statistical significance? Meaning, could it happen by chance? It could happen by chance. 39%, that's quite high. So I'd say it's not statistically significant because it's quite high probability that it could happen by chance. Does the weight loss program have practical significance? Meaning, if I did this diet, this weight loss program, 45 pounds, that's pretty significant. I mean, that's quite a bit of weight to lose. So I'm going to say, yes, the program is practically significant because the amount of lost weight is large enough to be considered practically significant. So I'm going to go there. Thanks.